The next thing we have to talk about is how to store strings of text. And because we already know how to store characters, we could use an int for that. It turns out that being able to store arrays really gives us everything we need. But before we talk about that, we have to meet one new type. And this is a type that actually appeared in the notes from week 1, but we sort of bypassed it. We didn't really need it until now. And it's a type called char. And it's sort of profoundly misunderstood. I mean, you see a type named char, and if it's introduced the wrong way, you make assumptions about what it's for. So let's set the record straight. Char is actually a numerical type. It's a type at the very shortest end of the integer spectrum. So we know already that we've got our standard type for int values is int. We also know that if we want more range, we can use long int. And that we also have long int if for some reason long int still isn't good enough. So we can see that the range is sort of going up as we go down the list. But it turns out that there are integer types with smaller ranges. There is something, maybe predictably, called a short int. So an int usually has a range of about -2 billion up to +2 billion. A short int has a range of about -32,000 to +32,000. And then at the absolute shortest end of the integer spectrum, there is this type called char. And it turns out that the reason it's called that is because we often use it to store characters. But a key thing is that it's just an integer type. It's an integer type with an extremely limited range. That's it. A range that's so limited that it's sort of useless for anything other than storing characters. If you want to perform arithmetic, you really don't want to work in such a small range. But let's just try using it for arithmetic anyway. All right, so I'll try compiling this, and I'll run it. And there you go. The value of ch is 10. And it turns out that char, because it stores values in the range -128 to 127, is a perfect type to use to store a single character. So I could store, there's the character uppercase A. And as we know, when we print out integer valued things, we can print them as a numerical value, or we can print them as an actual character. So let's try doing that. So we'll print it as a numerical value and as a character with %d and %c. Okay, and unsurprisingly, we get 65 and uppercase A. And we know already we don't care that much that A happens to be 65. We just care that every character has a number. Okay, so we have this type called char. We can use it to store characters. Why haven't we been using it to store characters? So there were even some people in the lecture feedback in September that were asking this. They were saying, we're learning about characters, Bill. We're learning about things like isUpper and toUpper. Why are we not using char? Because they might already know there is this type and it's often used to store characters. And there is a strange paradox inside the C language, which is that all of those character functions that we're familiar with, so functions like isUpper, and toUpper, and isSpace, and things that you might have used on midterm 1. All of those in ctype.h actually work with ints. There is this type that's ideal for storing a single character, and yet for some reason the library functions, which should be setting an example, they're our role models, they're not using it. And there's some complexity to that. There's some nuance to it that we'll see after the reading break, after midterm 2. We'll see why often it's useful to use an int to store a character. The key thing to understand right now is that it's not necessarily really any worse for the computer to use an int or a char, except in one case, which is that a char, because of its limited range, takes up less space in the computer's memory. And usually we don't care. The computer has tons and tons of memory, so using an int isn't a big deal. But if I'm going to store hundreds or thousands of characters, for example, if I want to store the text of a novel or something, then maybe I care how much space each character takes up. And that's one reason I would use char. And we're going to see that strings of text are often stored as arrays of type char. But talking about char gives us another thing we can think about, which is we know that these numerical types have ranges. We've been talking about that since September. What happens if we go outside of the range of a variable? So here I've got my value ch, which has the value 127, which I have claimed is the absolute upper end, the upper end of the range of the type char. So we'll print that out, we'll just see what happens. But the experiment is, what if I do something that results in that range being exceeded? Okay, so now the value is 127. And what if I manipulate this variable, let's say by adding 1 to it, so that the range is exceeded? So we know that the range of a char is extremely limited, which means it's a good place to play with this concept of limited ranges. If I add 1 to the maximum possible value of a char, what happens? And the answer is, it wraps around. If we ever exceed the high end of the range of a variable, the value wraps back around to the low end, and vice versa. If I go down lower than the low end, I wrap back around to the high end. We generally call this phenomenon overflow, the overflow of a variable. And of course, that's one more reason why we should not be using type char for arithmetic, because if we have such a limited range, it's really easy that we can go over that range. One example, let's try one more here, is if I were trying to use characters for arithmetic, then I could say, okay, how about this? CH equals 12. Well, 12 is easily within the range of a character. And now CH equals CH times 12. And we can see this is going to be computing apparently 144. That's the value of 12 times 12. But if we try running it, we'll notice that we get something nonsensical, negative 112. So what's happened is 12 times 12 is 144, but that exceeds the range. That's over the maximum allowed in a char, which is 127. And so the excess wraps back around, and we end up going up from the minimum, which is negative 128, to negative 112. So of course, we shouldn't be using a char for arithmetic, but for storing single characters, it's great. It takes up a bit less memory, and that's a great idea if we're going to be storing a lot of them in a row, which we're going to see we're going to be doing a lot of when we work with strings of text.